Have you ever looked up at the night sky, seen all those twinkling stars, and wondered, are we alone? It's one of the biggest questions humanity has ever asked, and today, we're going to dive into how scientists are actually starting to answer it. We're going on a journey to discover alien worlds. Now, when I say alien worlds, I'm not talking about little green men just yet. I'm talking about planets orbiting other stars. We call them exoplanets. For the longest time, these were just things we saw in sci-fi movies. But in the last 30 years, we've gone from knowing about 0 exoplanets to confirming over 5,000 of them. And that number is growing every single day. So how on earth do we find a tiny planet, hundreds or even thousands of light years away, next to a star that's 1 billion times brighter? It sounds impossible, right? Well, scientists are clever, and they have a few amazing tricks up their sleeves. The first and most successful method is called the transit method. Imagine you're watching a bright light bulb from across a huge room. If a tiny little fly buzzes in front of that light bulb, you wouldn't see the fly itself, but you might notice the light dim just a tiny, tiny bit for a moment. That's exactly what astronomers are looking for. Powerful telescopes, like the Kepler Space Telescope and now the James Webb Space Telescope, stare at thousands of stars at once, just waiting for that telltale dip in brightness. When a planet passes in front of its star from our point of view, it blocks a minuscule amount of starlight. The telescope's ultra-sensitive instruments detect this dimming, and if it happens at regular intervals, say every 30 days or every 365 days, that's a huge clue that a planet is orbiting that star. The time between these dips tells us how long the planet's year is, which helps us figure out how far it is from its star. A shorter year means it's orbiting closer. It's like cosmic hide-and-seek, and we've gotten really good at spotting the hiders. But that's not the only way. There's another cool technique called the radial velocity method, or the wobble method. Think about someone walking a big, energetic dog on a leash. The dog is running in circles, but it's so big that it's also pulling on the person, making them wobble back and forth a little. In space, a planet's gravity does the same thing to its star. As a planet orbits, its gravitational pull tugs on the star, causing the star to wobble ever so slightly. We can't see this wobble directly, but we can detect it by looking at the star's light. You know how the sound of a siren changes pitch as it moves towards you and then away from you? That's the Doppler effect. The same thing happens with light. As the star wobbles toward us, its light waves get squished together, shifting towards the blue end of the spectrum. As it wobbles away, the light waves get stretched out, shifting towards the red. By measuring this red shift and blue shift, astronomers can detect the wobble and confirm a planet is there. They can even use the size of the wobble to estimate the planet's mass. The bigger the wobble, the more massive the planet. So, we've found a planet that's amazing. But what's it like? Is it a giant ball of gas like Jupiter? Or a rocky world like Earth? The transit method gives us another clue. By measuring how much the starlight dims, we can figure out the planet's size. A bigger planet blocks more light. Now, if we have its size from the transit method and its mass from the wobble method, we can calculate its density. And density tells us a lot. If it's not very dense, it's probably a gas giant. If it's super dense, it's likely a rocky world. This is how we start to build a picture of these distant worlds. But the real holy grail, the question we all want to answer is, could any of these planets support life? To figure that out, we need to know if a planet has the most important ingredient for life as we know it: liquid water. For water to be liquid, a planet can't be too hot or too cold. It needs to be in what scientists call the habitable zone, or the Goldilocks Zone. It's that perfect orbital distance from a star where temperatures are just right. The size and heat of the star determine where this zone is. For a small, cool red dwarf star, the habitable zone is very close. For a big, hot star like our Sun, it's further out. So when we find a rocky planet of the right size, orbiting in the Goldilocks zone of its star, astronomers get really, really excited. These are the prime candidates in our search for a second Earth. But even a planet in the habitable zone isn't guaranteed to be friendly. It also needs an atmosphere. An atmosphere acts like a blanket, keeping the planet's temperature stable and protecting the surface from harmful radiation. But how can we possibly know if a planet light years away has an atmosphere? This is where the James Webb Space Telescope, or JWST, is an absolute game changer. Remember the transit method? When a planet with an atmosphere passes in front of its star, a tiny bit of starlight filters through that atmosphere. Different gases in the atmosphere absorb different colors or wavelengths of light. It's like a chemical fingerprint left on the starlight. By analyzing this light, a technique called transmission spectroscopy, JWST can tell us what's in the planet's air. It can look for the telltale signs of water vapor, methane, carbon dioxide, all gases we have in our own atmosphere. And this is where it gets really mind-blowing. Scientists are also looking for biosignatures. These are gases that are unlikely to exist in large quantities without life producing them. On Earth, for example, the high amount of oxygen in our atmosphere is a direct result of plants and algae doing photosynthesis. If we found a similar signature on another world, it would be the most profound discovery in human history. We're already getting our first incredible results. JWST has detected water vapor in the atmosphere of a gas giant and even carbon dioxide on a rocky exoplanet for the first time. We're not at the detecting alien oxygen stage just yet, but we're taking the first crucial steps. We're going from just knowing these planets exist to actually studying their weather and chemistry. So, what have we found so far? A wild and wonderful zoo of planets. We've found hot Jupiters, which are massive gas giants orbiting incredibly close to their stars with years that last only a few days. We've found super-Earths, rocky planets bigger than our own. We've even found planets orbiting two stars at once, like the fictional planet Tatooine from Star Wars. We've found planets made of diamond, and worlds where it might rain glass sideways. The universe is more creative and more bizarre than we ever imagined. One of the most exciting systems discovered is the TRAPPIST-1 system. It's about 40 light-years away, which is practically next door in cosmic terms. It has not one, not two, but 7 rocky Earth-sized planets orbiting a small, cool star, and at least 3 of them are in the habitable zone. This is a top priority target for the James Webb Telescope. Imagine an entire solar system of potential Earth-like worlds just waiting to be explored. The search for alien worlds has completely changed our perspective on the cosmos. We now know that planets are not rare exceptions. They are the rule. Nearly every star you see in the night sky probably has at least one planet, and many have whole families of them. That means there are billions, maybe trillions of planets in our galaxy alone, and our galaxy is just one of hundreds of billions in the observable universe. When you think about those numbers, the odds that Earth is the only special place, the only planet with life, start to seem pretty slim, don't they? We haven't found definitive proof of life elsewhere yet, but we're building the tools and the knowledge to do it. We're the first generation in history that has a realistic chance of answering the question, are we alone? The journey is just beginning. Every new planet we discover and every atmosphere we analyze is another piece of an enormous puzzle. It's a journey that teaches us not just about other worlds, but about our own, and our place in the vast, incredible universe. Thanks so much for exploring these alien worlds with me today. It's a topic that just blows my mind, and I hope it does for you too. If you enjoyed this cosmic adventure, please hit that like button and subscribe for more deep dives into the wonders of science. Let me know in the comments which type of exoplanet you find most fascinating. Until next time, keep looking up.